Today we will get to know about the work done by force due to gravity. In simple words, what is force due to gravity? Suppose this is the body over here. What is force due to gravity? The force with which Earth attracts any body, such as this is our body. The force with which the Earth attracts this marker, this body, that force is known as force due to gravity. And generally, in general words, we say that this force due to gravity that is acting on any body is the weight of the body itself. And you know about weight, what is it? Weight of any body is equals to m into g. Why so? Because weight itself is a force, and you know about force. It is equals to m into a, that is mass into acceleration. So suppose we have a body over here. This body, it experiences a force of m into a. We are doing it from the very beginning. The formula for force, that is m into a. Now this is the force with which Earth, it is the surface of Earth, it is the force with which Earth attracts any body. Suppose the mass of this body is small m. So the force exerted by Earth on this body will be equals to m into, the mass will be same, and instead of using this term, that is the acceleration, we use acceleration due to gravity, that is g, and this is only known as the weight of the body. So what do we conclude? The weight of the body, it is itself a force, that is the force due to gravity. So we have to discuss about the work done by force due to gravity. Suppose we have the same body over here. Suppose this marker, this body, it would be on the surface of Earth, and I have to lift it up. I have to change the position of the body. I have to increase the height of the body by raising it. Then what do? I have to exert some force on it. And what will be the magnitude of force that I have to apply on the body to raise it? It should be at least equals to the weight of the body itself. Suppose the weight of the body is 10 Newton. Then I have to apply a force of at least 10 Newton to raise it, to lift it up. So the force exerted by me, suppose here we have a body that is of mass m. You know, if the mass is m, then the weight of the body, it must be m into g. The weight of the body should be m into g. Now, if I have to lift it up, then I have to apply a force that is at least equals to the weight of the body. Like I told you earlier, if the weight of the body was of 10 Newton, then I have to apply at least a force of 10 Newton in upward direction to lift it up, to raise it. So here the force exerted by me, applied by me on the body, it should be equals to the weight of the body, and that is equals to m into g. Suppose now at some instant of time, I have lifted the body, I have raised the body, and the body has gained a height of small h. Then the displacement of the body is in upward direction, and the force applied by me on the body is also in upward direction, that is F, that is equals to m into g, weight of the body. Then we observe here that the force and the displacement both are in the same directions. So how do we find the work done? Work done by me, by us, is positive. But what about the work done by force due to gravity? Force due to gravity, as you know, force due to gravity will always be acting in downward direction. That is, force due to gravity, that is the weight of the body. So the force due to gravity, it is acting in downward direction. Now we are talking about the work done by force due to gravity and not the work done by me to raise the body. So the force due to gravity will be always acting on the body in downward direction. But what about the displacement of the body? The body is being displaced in upward direction, that is by a length, by a height h. So the displacement is in upward direction, but the force due to gravity is in downward direction. So the angle between both of them, the angle between force and displacement is 180 degree. So you know about work done. In that case, work done by force due to gravity, it will be equals to Fs cos theta. And you know about theta here. Theta is 180. So this part will be -1. The work done by force due to gravity will be negative. Minus sign. F that is equals to the force due to gravity, that is equals to m into g. That is the weight of the body itself. M into g is the force due to gravity on the body, and the displacement in upward direction is of magnitude h. So in this case, the work done by force due to gravity is minus mgh, that is negative. Why so? You know, the displacement is in upward direction, but the force due to gravity is acting in downward direction. So the work done by force due to gravity in this case is negative. Now suppose we reverse the case now. Now the body is not being raised, it is not being uplifted, but it is falling freely under gravity. Suppose that there was a body at some height and it starts to fall. It's a very common example. We have this body over here. As soon as you leave it, what do you observe? It starts to fall. It starts to move towards the surface of Earth. So, suppose the mass of this body is small m and it starts to fall freely under gravity, and finally it comes to the surface of Earth and it comes to rest. This is our Earth surface. Now, suppose in this process the body, it covered a displacement of h, small h. It means that the body had a displacement of h in coming from this position to this position at the surface of Earth. What about the force that is responsible for this? Obviously, there is no external force rather than the force due to gravity. So the force due to gravity, it is acting on the body in downward direction. It will always be acting on any body, lighter, heavier, any body. So the force due to gravity, it is acting on the body in downward direction. And you know about the magnitude, that is equals to m into g. So the force is acting in downward direction and the displacement of the body, it is also in downward direction. So there is no angle between them. It means that theta here is 0 because both of them are in the same direction. So the work done will be directly equals to F into S, because cos theta, that is cos 0, will be 1. Let me explain it to you. Fs, cos theta, the angle between them is 0, and you know that cos 0 is 1. So the value of F, force due to gravity, that is m into g, and the displacement here is h. So in this condition, the work done by force due to gravity will be positive, because both of the things, both of the physical quantities, the force and the displacement, both are in same direction. So these were the two cases, basic cases about work done by force due to gravity. When will it be positive? When the body is falling freely under gravity, the work done by force due to gravity will be positive. And when the body is thrown in vertically upward direction, then the work done by us will be positive, but the work done by the force due to gravity will be negative. That will be minus mgh. So that was about the work done by force due to gravity. Now we are moving to the case when the work done by any force would be 0. You might be asked about it, that what are the conditions when the work done by a force is 0? Conditions for work done to be 0. One of the cases is already known to you. The very first condition, and obviously the force must be applied to the body. If there is no force being applied to the body, then obviously the work done will be zero. So you will be asked that if we are exerting a force on a body, then what will be the condition for the work done to be zero? It means after applying a force to the body, there is no work being done. The work done is zero. So the first condition will be there is no displacement produced. As I told you earlier, if I am exerting a small or a larger force on this board or on this wall, it is not going to move anywhere. It is not being displaced. So it doesn't matter that how much force I am exerting on the wall, on the board, I am doing no work. The work done will be zero because the displacement is zero. Displacement no displacement is being produced. It means that we denote displacement by S in general. So there is no displacement produced. It means that the displacement is zero. And the second case, you know about it. When the force and the displacement are perpendicular to each other, the angle between the force and the displacement is 90 degree. So what is the condition? The second condition, the displacement of body should be normal or perpendicular to the direction of force. In both the conditions, if the displacement is zero, then it's very clear to you. With the help of this expression, if the displacement is zero, then the work done will be zero. And if we are applying some force and the body is being displaced also, but the theta here is 90. It means that the force is perpendicular to displacement, or we can say that the displacement is perpendicular to force. So here theta will be 90, and as you know, cos 90 is 0. So in this case also the work done will be 0. So that was all about work. Now the next part is about power. What is power? Whenever you hear that this term is being used anywhere, such as in electricity also, you will get to know about this term. You will hear this term, that is power. But there we will use the term electrical also with it, that is electrical power. But firstly, let us know that what is power. We represent power by P. What is power? It is defined as the rate of work done. The rate of work done, it means that whenever we use this term rate means per unit time. That is, either you can say that what is power? It is the rate of work done, or we can also say that it is the work done. It is the work done by any body per unit time. So both the statements, they define power. Either you can say that it is the rate of work being done by any body, or we can say that it is the work done by any body per unit time. So basically, if you have the condition that a boy or a girl, he or she does some work of 100 joule work, he or she is doing a work of 100 joule in a time interval of 2 seconds. Then the total work done here is 100 joule and the total time taken is 2 seconds. So if we are asked that what is the power developed by the boy or by the girl, then what do? Simply, what is power? As I told you, it is the rate of work done, or it is the work done per unit time. So here, from the very beginning, we'll get to know about it. Power. The condition over here is given to you. In 2 seconds, the work done is of 100 joule. Then we apply unitary method here. 1 second. In 1 second, how much work will be done? How much work will be done? 50 joule of work will be done. So in 1 second, 50 joule of work is done. And obviously, the rate of work done or the work done by any body per unit time. It means that in 1 second how much work is done? 50 joule of work is done. We can write it like this also. 50 joule per second. That means 50 joule of work is done in 1 second, and this is only the power. So the power developed is 50 joule per second. Now we will be talking about the unit of power. The SI unit of power is watt. Again the same part. It will be represented by capital W. So the SI unit of power is watt. Now if I ask you to define 1 watt of power, then what do? I told you earlier the process, the steps that you should follow to define any of the units. What do? I asked you to define 1 watt of power. Then as you know, what is watt? Well, the watt, it is the unit of power, SI unit of power. So firstly, you write the expression for power, that is work done per unit time. So you have to define 1 watt. What do? Magnitude will be 1 for all the physical quantities. So work done will be also 1 joule and time will be of 1 second. Now you can define it of your own. What is 1 watt of power? If 1 joule of work is done in 1 second, then the power developed is of 1 watt. Very simple it is. Now, if in a situation there is no work done by anybody, or you have no idea of the work being done, then what do? We will simplify it. P is equals to W by T. What is W? What is W? It is the work done. And you know about work done. Work done, it is equals to F into S. That is force into displacement. And you know about S by T. That is displacement by time. What it is? It is speed. It is velocity. So if force is given to you, if you are provided with the information that the force exerted on a body is of X Newton and the velocity of the body is of something u meter per second, then by this expression also you can find the power developed by the body. No need that you are only provided with this data, with the data of work done and the time is also given to you. Instead of this, you can also be provided with the information about the force and about the velocity. So it is the other expression for power being developed by anybody. Now, as you know about power, the rest of the units for power, the bigger or the smaller units, you can obtain it by adding the prefixes that you have known earlier, such as if I ask you for some bigger units, so what do? With what? You will use the prefix kilo, mega, giga, such as if you write down 1 kilowatt, it will be equals to 1000 watt or 10 to the power 3 watt. So there are more units for it: kilowatt, megawatt, gigawatt, etc. The very general unit that is used oftenly, that is horsepower. It is abbreviated as H.P, horsepower. Now, it will be very useful to you. Sometimes the power will be given to you in horsepower and you will have to convert it to watt or kilowatt, anything. So 1 horsepower, it is equals to 746 watt. It is the relation between horsepower and the SI unit of power. It might be used in your numericals also. So 1 horsepower, it is equals to 746 watt. That was all about power. Now we can move to the numerical part. So here we have a simple example that is relatable to work and power. So what is the question? I'll read it for you. A boy of mass 40 kg climbs up the stairs and reaches the roof at a height 8 meter in 5 seconds. So suppose that the boy was here on the ground, on the earth's surface, and he started to climb over the stair, and finally he reaches the roof, and the roof is at a height of 8 meter above the ground. One more thing, if it is given to you in the numerical, then it is okay, 10 meter per second square, and if it is not so, then you will take the value of g to be 9.8 meter. So he reaches at the roof, that is at a height of 8 meter above the earth surface, above the ground. And in how much time that is given to you? He did it in 5 seconds. The first part, it is being asked that what is the force of gravity acting on the body? I told you in the last video that what is force due to gravity? The force with which earth attracts the body. And here the body is the boy. He has a weight of 40 kg. So what is the force due to gravity acting on the body, on the boy? The force due to gravity, or we can say that the weight of the boy itself. The weight of the boy, or the force due to gravity acting on the boy, it will be equals to m into g. The first part. That will be equals to m into g. As you know about the mass of the boy, that is 40 kg multiplied by the value of g, it is given to us, that is 10. The SI unit for force, that will be Newton. So the weight of the boy here is 400 Newton. Or you can say that both of the statements are the same. The force due to gravity acting on the body, acting on the boy, or the weight of the boy. Because the weight, what is weight? The weight is the force which with earth attracts a body. So it was the first part. That is 400 Newton. The second part, the work done by him against the force of gravity. So, as you know, the boy, if he is climbing on the stairs, then he has to exert a force in upward direction that is equals to his own weight. Now, we got to know about the force, about the weight, the force due to gravity that is acting on the boy, that is of 400 Newton. Suppose that I have a weight of 400 Newton. Then, if I have to climb up the stairs one by one each of the steps, then what do? I have to exert a force in upward direction that will be at least be equals to my own weight, that is 400 Newton. So, the work done by him against the force due to gravity. What is work done? You know about it, F into S. He has to exert a force in upward direction that is equals to his own weight. So the force exerted by him in upward direction should be at least equals to his own weight. The force due to gravity, that is 400 Newton, multiplied by, what is the displacement here? The displacement is of 8 meter. So obviously the boy has to, as he is climbing upstairs, he has to exert a force in upward direction only, and the displacement here is also in upward direction. So directly we use the expression F into S. What is it? What is the work done here? 3200, as both of them were in their SI units, 400 Newton, and displacement is in meter. So the work done will also be in its SI unit, that is joule. So the work done by him against force due to gravity is 3200 joule. I think it must be clear to you. Now we move to the third part. The power spent by the boy, or the power developed by the boy. We can use either of the terms, spent or delivered. Delivered in the case of appliances. So, for power, you know about power, that is work done per unit time. He is doing a work of 3200 joule, and the time is also given to us. In the whole process, he takes a time of 5 seconds. So here we have the time also. The result, as both of them are in their SI units, so the power will also be in its SI unit, that is watt. So this will be the power. You can find it of your own. So this was a simple example that is relatable to work and power. In the last class, I told you that how can we derive the other form of the other form of this equation, that is P is equals to W by T. Power is equals to work done per unit time. The other form for this expression was F multiplied by V. That is force applied on the body. It will be multiplied by the speed of the body. Speed, that is the body that is moving, its speed. Now, we have a question over here that will make our concept more clearer. And I'll read it for you. An ox can apply a maximum force of 1000 Newton. The ox can apply a maximum force of 1000 Newton. It is taking part in a cart race and is able to pull the cart at a constant speed of 30 meter per second. Now, what do you notice here? Both the parts, both the physical quantities are known to us. The first one, that is the force, maximum force that can be applied by the ox, that is of 1000 Newton. And the next part, that is about the speed. The constant speed of the cart that is pulled by the ox is of 30 meter per second. Now, what are we being asked? We have to find the power developed by the ox. So, what will be the power developed by the ox? We can find it. Very simple it is. The force, it is given to us 1000 Newton into the speed of the cart, that is of 30 meter per second. Both the quantities are in their SI units. So, the power we get will also be in its SI unit, that is in watt. So, our solution will be 3 into 10 to the power 4 watt. This is the power developed by the ox. I think it must be very clear to you the concept of power, and with the help of this example we got to know that if the part work and time, it is not given to us directly, in spite we are provided with the information of force and speed of the body, then we can use this expression to find the power developed by the body. Now, in the next part, we will get to know about energy.